Okay, so let's take a look at that first example. It wanted us to graph it. So if I'm thinking about my graph, there's been no stretches or shrinks, right? It's the same width as a parent function parabola. So I'm just going to worry about the shifts here. What does the -2, -6 mean? What has happened to your graph?
Right 2 down 6.
Right 2 down 6. So my vertex has gone from 0, 0 to 2, -6, right? We went right 2 down 6 for my vertex. All right, then as for my axis of symmetry would be at x equals what? 2. Very good. It's going to be the same x value as what I use in my vertex. So my axis of symmetry is going to be right here. Y-intercept, if I plug in 0 for y, I got to figure out what, plug in 0 for x, I have to figure out what my y value would be. If I plug in 0 for x, what would I get? 0 minus 2 is -2. And then when I square -2, that would become what? Positive 4, and then -6. So -2. And because we have symmetry on both sides of that axis, I can make a mirror point. So the general shape of my graph is going to look something like this. Okay? Really, that's not super exact. Let's see if I can make this look a little bit better. Okay, so that looks a little bit better. But you can see I don't know what the x-intercepts are right now. So if my follow-up question is what are the solutions, it's kind of hard to tell from what I have graphed. So I'm going to go ahead and type it into my graphing calculator. I'm going to go to y equals, and I already have typed in x minus 2 squared minus 6. I'm going to press graph. Now look at my graph. See how it kind of goes in between those intervals? So it's kind of hard to tell still what those x-intercepts would be. What tool can I use on my graphing calculator to get those x-intercepts? Second what? What on this graphing toolbar is going to help get my answer? Second, calculate is what I had you write down in the notes yesterday. Right? What is a synonym for x-intercept or solution? 0 is a synonym. Okay. I'm going to arrow over to one of the x-intercepts. And it wants the left-hand side of that x-intercept. So I'm going to go a little bit to the left of it. Press enter. Right bound. Back at my intercept, I want to go a little bit to the right of it. So I'm going to hit the right arrow and press enter. And then it says, do you want me to guess your x-intercept? And you press enter. And here's my first x-intercept. -0.4, 0, approximately. Is that what I had on my graph? -0.4. It was close. It looks like I went through -0.5, right? So we were close there. All right, now I'm going to do the other one. Second calculate or second trace. 0. I'm going to arrow over to my other x-intercept. And it wants the left bound of it. So I'm going to press my left arrow so that I go a little bit to the left of it. And press enter. Then I'm going to press my right arrow and go a little bit to the right of it and press enter. And I'm going to press enter again to calculate it. And it looks like it's at 4.4 approximately. Let's see how off I was on my picture. 1, 2, 3, 4. It looks like I'm nearing 5. Really, it should be 4.4. So really, I should have had a point at 1, 2, 3, 4.4. I should have a point right there. So it was a little bit too wide. Any questions on that? Nice tool to have. Second calculate is 0. All right, now down here, I've got -x² plus 4. If I want my x-intercept, I plug in 0 for y, and I'm going to try to solve for x. That's how I get an x-intercept. right? Plug in 0 for y, solve for x. I want to try to factor this. Right now, I hate having a negative sign in front of x squared. If I can factor that out, I always do that. So I'd factor out the negative, -1 if you want. Okay, the first term divided by -1 would just leave you with a positive x squared, and the second term divided by -1 would be -4, right? X squared minus 4, what kind of factoring technique can I use with x squared minus 4? Dots, grouping, guess and check, what would you use? Dots, difference of two squares. Isn't this a difference of two perfect squares? What's x squared a perfect square of? X. And what's 4 a perfect square of? 2. So I use a plus b, a minus b. I'm going to do x plus 2, x minus 2. See how now it's in intercept form? Once it's in intercept form, you can set each of those factors equal to 0 and solve. Here, if I subtracted 2 on both sides, I get a solution of -2. Here, if I add 2 on both sides, I get a solution of +2. Those are your intercepts. -2, 0, and +2, 0. So I want my vertex. Remember, I'm using -b/2a for standard form. The only problem is I don't have an x term. So what placeholder could you use? -x squared plus 0x plus 4, right? You don't have an x term, it's a 0x. -b, my b value is 0 over 2a. A is -1. So I'd end up with 0, something. What do I get when I plug in 0? What is my y output? What do I get? Alan, what do I get when I plug in 0? This is 0 squared plus 0 times 0 plus 4. 4. 1, 2, 3, 4. So here's my vertex. Okay, it's also your y-intercept. Okay. It gives us a good idea about what the graph looks like. It looks something like this. Why does it make sense that that graph looks opening down? What about my formula, that original function, tells me that my graph should open down? Oh. Great, there's a negative in front of the x squared. What does that negative mean? We're going to vertically reflect our parent function. Okay, right? Reflect over the x-axis, so it should open down. Cool. Any questions about either of those graphing problems? Okay. All right, so now what we're going to do, if you look at this core concept box, yesterday we talked about solving by graphing. Today we're going to solve using square roots, and we're going to solve by factoring, which we've kind of already been solving by factoring, so we're just going to do some more with that. Okay, I need you to flip it to where it says solving quadratic equations using square roots. This is how I know to use this method. Use this method with x squared or some quantity squared when there's no x term. Okay? So if I see an x squared in the equation with no x term, then I know to use solving using square roots. See how in this equation you see an x squared term but no x term? That's how I know how to solve, that's how I know to use square roots to solve this. Okay? Same thing with part C. I see a quantity squared, okay, but I don't see an additional x term outside of those parentheses. Okay, so if I see a quantity squared with no additional x term outside the parentheses, I know that I'm going to solve the quadratic equation using square roots. Okay, that's what clues me into it. So looking at this first example, part A, I'm going to solve using square roots, and I need to try to isolate the x squared term. So how would you start this? Cindy, what would you do first to try to get the x squared term by itself? Even before I divide by 4. Nope. I want to get this by itself. What do I want?
Just add 31.
Yeah, add 31 to both sides. Yeah. So I get 4x squared equals 9 plus 1 is 10, carry the 1, 4, 5, 6, 7, plus 1 is 8. 4x squared equals 80. Okay. Now the x squared term is by itself, okay. But I just want x squared on this side. Okay. What's the inverse of multiplying by 4? Dividing by 4. So the next step is I'm going to divide both sides by 4 before I take the square root. 80 divided by 4. Let's see, 8 divided by 4 is 2, so this must be 20. Alright, what is the inverse of squaring an expression? Square rooting an expression. One operation undoes the other. So to get x by itself, I'm going to square root both sides. So I'm left with x equals the square root of 20. What am I missing? Plus or minus. Whenever you are putting a square root in yourself, you are physically drawing in the square root sign, you need to put a plus or minus. Yeah. You would. So you're one step ahead of me. You said, do you have to simplify that radical? Yes. Now, is radical 20, is 20 a perfect square? Okay. So it's not just going to be a nice, neat whole number, right? It's going to be something that's a little bit different. So since 20 is not a perfect square, this is what I do. I think about the factors of 20. 1 and 20 are factors of 20. What else would multiply to give you 20? 2 and 10, right? What else? 5 and 4, 4 and 5. Okay, so these are all the factors of 20. 20 is divisible by all of those numbers. What I want to do is I want to pick the largest perfect square that 20 is divisible by. You want to pick the largest perfect square that 20 is divisible by. So I start with my biggest number. That's why I wrote them in order. Is 20 a perfect square? Is 10 a perfect square? Is 5 a perfect square? Is 4 a perfect square? So 4 is the largest number that's a perfect square that 20 is divisible by. So I'm going to use that. X equals plus or minus the square root of 4, there's my perfect square, times what? 4 times what gives me 20? 5. Okay, so I just broke 20 down into 4 and 5. Okay, but I chose 4 because it's the largest perfect square it's divisible by. Now that I have an equivalent expression, I can go ahead and continue simplifying this. X equals plus or minus. Because I have multiplication here, I can break this into radical 4 times radical 5. And which radical simplifies? The radical 4 or the radical 5? Radical 4, right? That's the whole reason why we chose a perfect square, was so that I could simplify that portion. Okay, so we get plus or minus 2 radical 5. I had someone in my last class ask me, do you have to choose the largest perfect square? What if I just chose a perfect square, but it wasn't the largest one? That's fine. It'll help you simplify your expression a little bit, but you're still going to have a number underneath that radical that's divisible by a perfect square. So you're going to have to do that simplification process twice. I personally hate doing more work than what I have to. So it's the benefit of choosing the largest perfect square, just right off the bat, is that you only have to do simplification one time. Okay? How many solutions is this? 2. The plus or minus gives you 2 solutions. A positive 2 radical 5 and a negative 2 radical 5. Okay, so if I were to ask you how many solutions, you would say 2. Any questions on that first one? Alright, so for the second one, we've got 3x squared plus 9 equals 0. We need to try to isolate the x squared term. Gabby, how would you start this? Great. Subtract 9 from both sides. So we get 3x squared equals negative 9. Now I want to try to get that x squared by itself. So what would you do next? What would you do next? Paige, what do you think? Divide by 3 on both sides. Good. X squared equals negative 3. And then what is the inverse of squaring something? Say it loud. Square root. Good. So I'm going to square root both sides. X equals plus or minus the square root of negative 3. I see a negative underneath the radical. Can you take the square root of a negative number? Let's think about a different example. Let's think about like the square root of negative 4. Okay. I know that 2 times 2 is positive 4. Is there a way to multiply something by itself to get a negative number? What would you do? Like negative 2 times itself is still a positive 4, right? There's really no way to take a number and multiply it by itself and get a negative number. Anytime you take a number and multiply it by itself, you're essentially squaring that number. If you square a number, are you going to get a negative number? No. So if we see something like this, where we have negative under an even root, whether that's a square root, a fourth root, a sixth root, anytime we have a negative under an even root, you're going to write no real solution. Okay? The real part's important because we're going to get into imaginary solutions a little bit later. Okay, there's just no real solution. And let's talk through this last example here. All right, so in this last example, this is an example where I see a quantity squared. I want to try to get that quantity squared by itself. Right now, see how there's a 2/5 in front of it? How would I get that quantity squared by itself? How do I undo multiplication by 2/5? Great, multiply by the reciprocal. A lot of people, when I say what's the opposite of multiplying by 2/5, they would tell me divide by 2/5. But dividing by 2/5 can get messy. Okay? So instead of dividing by a fraction, we multiply by the reciprocal. Good. So I'm going to multiply this side by the reciprocal, which is what? What's the reciprocal? 5/2. And I'm going to multiply this side by the reciprocal, 5/2. Oops. Okay. When I multiply this side by the reciprocal, 5 divided by 5 is 1, 2 divided by 2 is 1. So we're just left with x plus 3 squared. And over here I'm doing 5 times 5/2. I like thinking about this like it's 5 over 1, so that I can do top times top to get a new top, bottom times bottom to get a new bottom. Right? When you multiply, you just multiply the numerators together, get an answer. Multiply the denominators together, get an answer. So 5 times 5 is 25, and then 1 times 2 is 2. Okay, 25/2. Okay, now this expression is isolated. We have some quantity squared. I'm going to square root both sides to undo that squaring operation. So this is what I'm left with. Okay. Plus or minus, plus or minus, plus or minus. Make sure you put that plus or minus whenever you're drawing in the square root. Now, 25 over 2 is underneath that square root sign. Keep in mind you can square root 25 and square root 2 separately. Okay? Why is that helpful to know that information? What is the square root of 25? Just 5. I always want to simplify my answers as much as possible. So I've got x plus 3 equals plus or minus 5 over radical 2. Is there anything that you remember from geometry that you're looking at and you're like, ooh, that's not simplified? You know what I'm saying? Good. She said multiply the bottom by radical 2 and the top by radical 2. Why would you do that? What's the problem with this expression? You don't want to leave a radical in the denominator. Okay? So in order to get that radical out of the denominator, we, what's that R word? Rationalize. There it is. Yep. Rationalize. Okay? So I'm going to multiply the top by radical 2 and the bottom by radical 2. Okay? Multiplying by radical 2 over 2 is like multiplying by 1. You're not changing anything. It's just a different way to write it. Okay. So we have x plus 3 equals plus or minus 5 radical 2 over radical 2 times radical 2 is radical 4, or what's radical 4? 2. Okay, so that's looking better. Still trying to solve for x. What's the last thing I need to do to solve for x? I get x by itself. Subtract 3 from both sides, yeah. Subtract 3 here, subtract 3 there. So I get x equals negative 3 plus or minus 5 radical 2 over 2. I like to keep the constant out front. This is also an acceptable answer. You could have plus or minus 5 radical 2 over 2 minus 3. That's also acceptable. You just want to make sure that that plus or minus stays in front of the 5 radical 2 over 2. Think of it like it's glued to that expression. How many solutions is that? Is that one solution? No. Why? Why is it more than one solution?
Positive solution.
Yeah, you got this plus or minus in the middle here, right? There's two different solutions. You can either write, you can either write x equals negative 3 plus 5 radical 2 over 2. Right, that's one solution. Or my second solution is that x equals negative 3 minus 5 radical 2 over 2. You can write your answer this way, but just know on a multiple choice test, if this does not appear as a possible solution, maybe I broke it up into two separate solutions, right? You need to feel comfortable writing it as two different solutions, one with the plus and one with the minus. Any questions about that? Okay, so there's a couple review elements that I incorporated into here, which you might want to just star so you remember. Rationalizing, that was a review element. Simplifying a square root, right, where we broke the square root of 25 over 2 into the square root of 25 over the square root of 2. And same thing with this. Simplifying radicals, okay, choosing the largest perfect square that a number is divisible by. Okay, so those are all review elements from geometry and algebra 1. All right, last topic we're going to talk about today is solving quadratic equations using factoring, which we've kind of already been doing. Please don't forget to set the equation equal to 0 before factoring. You have to have it in standard form. Ax squared plus bx plus c equals 0. You have to have it in that form before you start factoring. Do not factor unless your equation is set equal to 0. The zero product property says if the product of two expressions is 0, then one or both of the expressions equals 0. Okay, we'll see that here in a second. All right. Example 3. Can I start factoring right now? Is that in standard form? No. You have to get it in standard form first. Write a big old note to yourself. Subtract 45 on both sides first. Okay, I subtracted both sides by 45 so that I could set that equal to 0. Now that it's in standard form, now I can factor. Look at your sign. I put a negative sign in front of 45. So are the signs in my parentheses going to be same or opposite? If the last times last is a negative number, how do I get a negative number? Opposite signs, right? Plus and a minus. Okay. So let's keep that in mind. X times x is x squared. Last times last, we want it to be 45. What are some factors of 45? 9 and 5. I think that'll work, right? 9 and 5, is there a way to get to negative 4 using 9 and 5? Yeah, which one would have to be negative, 9 or 5? 9 would have to be negative, right? 9 is negative, 5 is positive. Check your outers and inners and make sure it adds up to negative 4x. Okay. Now that this product equals 0, I have to think to myself, how would I solve for x? Well, either x minus 9 would equal 0, right? If x minus 9 equals 0, you'd have 0 times x plus 5, which is 0, right? 0 times anything is 0. Or what's your other case? X plus 5 could also equal 0, right? Because if x plus 5 was 0, then 0 times x minus 9, what does that be, 0? That's your zero product property. Okay? If you want a product that's equal to 0, one or both of those expressions have to be 0. Now I've got two simple equations to solve. Add 9 to both sides here. We get x equals 9. Subtract 5 from both sides here. And we get that x equals negative 5. Cool. Alright. Last guy, it says find the zeros of f of x. What's a synonym for zeros? What's a synonym for zeros? Zeros is the same thing as what else? X-intercepts. You got zeros, x-intercepts. Another word. Solutions. There's another one. Starts with an R. It's like what trees, you know it? Root. Good. I was like, it's like what trees have in the ground. Yes, root. Those are all the same thing, essentially. So if it says find the zeros, it's essentially just asking us to find the x-intercepts of that function. Okay? Now, how do I find an x-intercept? If I want to know what my x value is, what do I plug in for y? 0, right? It's asking to find the x-intercept. We're replacing y with 0, and we're going to solve for x. Okay? You cannot start a factoring problem unless it's set equal to 0. So if it says find the zeros, set it equal to 0. Okay? So now I can factor this. 0 equals, I see a plus here. Last times last is a positive number. So are we going to have same sign or opposite sign inside the parentheses? Same, right? But if I look back and see that this b value is negative, is it going to be a plus plus or a minus minus? Minus minus, right? We've got a negative b value. Okay. 2x times x is 2x squared. Last times last should give me 12. What are some factors that give me 12? 1 and 12, 2 and 6, 3 and 4, 4 and 3. Remember, whatever I put in this outer blank here is going to be multiplied by 2. Whatever I put in this inner blank is going to be multiplied by x. Anybody think of what factors they would fill that in with? Two where? The first blank?
Yeah.
Let's try it. 2 and 6. The outers would be 12x and the inners would be 2x. So 12 and 2, not quite. We're there. We're close. 3 and 4 maybe? Alright. 3 in the first blank. 3 and 4. Outers would be negative 8x. Inners would be negative 3x. Yes, that does get me to negative 11x. Cool. All right, what do I do with the factors? Now that I have it in factor form, now what do I do? I set each factor equal to 0, right? It's either 2x minus 3 would be 0, or x minus 4 would be 0, right? So that we get that 0 product. And I'm just solving these two simpler equations. That's how you get x. So here, if I add 3 and divide by 2, we get 3 halves. Here I'd get 4. All right, your homework this weekend is just on solving using square roots and solving by factoring. So, please do that.